Okay, so good evening, everyone. I welcome you back to my YouTube channel presenting before this wonderful tutorial is the mentor Hambi Kliman. So today we are going to be doing set operations, a very interesting part of set theorem which people get to have quite a lot of challenges. We are going to do the first question, which simply states that given that x and y are disjoint sets, simplify x complement union y complement. What are disjoint sets? Disjoint sets are simply sets that have nothing in common. So in this case, if we are to solve the first question, okay, so if we are to solve the first question, okay, so we have the solution there. We solve the first question. Notice that the two sets are disjoint sets. So in this case, we are going to have x as a set having nothing in common with y as a set. So these two sets are separate. Then we have been taught that we simplify this. Okay, we simplify that. How do we simplify x complement union y complement? How do you solve this? Well, to simplify this, use De Morgan's law. So you have x complement union y complement. This is just the same as x intersection y complement. You can get what is inside. X intersection y, because these two are disjoint sets, they have nothing in common. The intersection of these two sets is simply the empty set. Henceforth, x complement union y complement is equal to the empty set complement. Complement of the empty set is going to give you the union set, the universal set, or the union set, the union set, or the universal set. Because if you do complement of the empty set, you are saying everything outside the empty set, you're going to remain in the universal set. Henceforth, x complement union y complement is going to give you the universal. That is the final answer. We go to question 2. Given that P and Q are any two sets, express the following in its simplest form. So we have they're saying we have P complement intersection, then we're going to have P union Q. Okay, like that. Let me check. All right. So how do we solve this one? P complement intersection, distribute a complement in the brackets. So this is going to be P complement. Complement exposed to the union set becomes the intersection set. Complement exposed to Q is going to become Q complement. Let's do factorization. P and P are common, so P is going to be factored out. The intersection and the intersection are common, so this is going to be the intersection outside. Notice that we factored P out, so we are going to remain with only Q complement. Henceforth, this set is simply P complement intersection Q complement. And that is our final answer. We go to B. B, they're saying, okay, so we are going to have P intersection Q. This is very simple. So we have P, then intersection Q complement. How do we go about solving this particular question? Well, it's very simple. We are going to factor out P and P. Then we can factor out the intersection and the intersection. We are going to remain with Q because Q is not common. Here we have Q complement. So Q is going to remain. Then we distribute the universal and we are going to have Q complement. Now, Q union Q complement is going to give you the universal set. Okay? Always know that Q union Q complement is going to give you the universal. Probably Q intersection Q complement should give you the empty set. So P intersection, this is the universal set. Always know that. Then P intersecting with the universal set is going to be P as a set. That is the simplest form of this particular question. We go to C. C, they're saying we have okay, so this is going to be P, this is going to be P complement intersection Q complement complement. Complement exposed to P becomes the set P. Complement exposed to Q complement becomes the set. So complement exposed to the intersection, it becomes the union set. Complement exposed to Q complement becomes the set Q. That's how you solve that. Go to the last to C, to D. They're saying we simplify this. Is P intersection Q complement union, and then this is going to be P, then intersection Q complement, then complement. So how do you go about solving this? Complement exposed to this P, it becomes P complement. Complement exposed to the intersection set becomes the union set. Then complement exposed to Q, it becomes Q complement, right? Complement exposed to the union set, it becomes the intersection set. Complement exposed to P, it becomes P complement. Complement exposed to the intersection set becomes the union set. Complement exposed to Q complement, it becomes the set. So P complement and P complement are common. We can factor them out. Union set and the union there becomes common. We can factor it out. And then we are going to remain with only Q complement. Then we distribute the intersection with Q set. Notice what I taught here. This is same as the empty set. So P complement union, this guy is simply the empty set. So P complement union the empty set is going to be P complement. How is Q complement union Q becoming the universal? if the universal set is equal to 1, 2, 3, 4, 5, 6, and Q is a set such that it is 1, 2, 3, then Q complement is going to be everything that is outside Q. So we are going to remain with the universal, and that is going to be 4, 5, and 6. Notice that these are everything of the universal set. These are members of the universal set. In other words, what you are going to remain with are members of the universal. You remain with the members of the universal set. Okay, that is how everything is happening like that. If you have Q complement intersection Q, you cannot have, this is everything outside Q intersecting with everything in Q. Okay, it will not give you the answer. It will give you an empty set. You cannot intersect what is outside Q with what is inside Q. Okay, it's not making sense. So it gives you the empty set. That is how we're able to do those operations. If you understood what I was doing, I want you to do E and F and send the answer to me. If you enjoyed this video and you understood, consider subscribing, commenting, and sharing, and hitting the like button, also sharing to others. Thank you so much.